Good morning, mathematicians. Hope you've been improving. Oh, actually, I didn't intend to reveal this, but this is part of the script. Well, I mean, just working out details ahead of time for the categories of module series. Which, let me see, 251 views 13 days ago. Math subject political compass 16 hours ago, 1.4k views. People just want the memes. So I give you guys memes, but then I gotta I gotta say my piece about modules here and there in between.
This is 13 days ago.
Hello, Edit Smith. Hello, Edit Smith. So, yeah. But who knows? Maybe if I make other series. This is why I made a poll recently to see what people wanted series on. But there didn't seem to be a unifying opinion. Well, maybe if we go take a look at the poll. Thanks. I'm glad you agree. Yeah, I thought it was good. Yeah, possible. Ooh, what is this? An unhealthy. Ooh, new sheafification of G just dropped. Okay, I'd forgive everyone for abandoning my live stream to go watch sheafification of G. You'd be forgiven. Yeah, we've got a little... both of these kind of count as homology formal proofs. I do think I will make... absolutely 100% gonna make videos on maths. Yeah, there's two... The only... Yeah, no unifying opinion. Mind you, yeah, I guess if I look at the likes... Lie algebras, especially the exceptional ones. 7 likes. And then another comment with classification of Lie algebras with 3 likes. That's probably most likely. Affine scheme stuff is coming, no matter what, at some point. Very slowly. This is all very slow, long term. Long term plans for videos. But in the news, big news, we have a pope. We have a mathematician pope. At least a bachelor's in... oh, in case anyone wanted to know what career options are available if you just stop at your bachelor's. Yeah. So, am I overqualified to be a pope now? That's too bad. Not that I had, ambitions of being a pope, but to know that door is closed now, forever. Although, who knows? Maybe, this pope will be successful, and they'll just be like, wow, imagine what we could have with a Ph.D. That's interesting. That's interesting. I would not say that's a normal thing. Mind you... certainly when you're in the middle of a course, right, you get used to thinking of certain... trying to think of a certain way or certain tricks. Actually, there is one proof... There's a recent proof I came up with that I don't understand how... I feel like it was an accident. It's a little... I've been hinting at for a while that there's a little side project I have in graph theory. And I have no idea. Those are so many other things that take priority over publishing that paper. But I did talk to a graph theorist at a conference. And I asked her if maybe this summer I could send her like a draft of my paper. Because I think it's maybe taking shape. Of course, as I dig into it, there's always like more things to do. And um, anywho, there's a proof in it. It's I think one of the more main results possibly. It's not very long. It's not, but it took me a long time to think of it, and I feel like I hit on the idea almost by accident. And I'm still like, yeah. How did I come up with that proof again? That doesn't seem. Yeah, it's surprising to me now, like a couple weeks in the future. Um, anyone who says this person should do anything other than two is out of their mind. Hello, Music QFD. Good morning. Yeah, these other styles are insane. Number two's this is it. This is what you should be doing. Well, this is I don't know. This is a whole can of worms. Do I want to open it? I didn't even look at it yesterday when I scrolled past it. What is your broadest acceptable definition for a set to be described as numbers? I don't know. I don't think I care, actually. I don't think I care. I mean, this person draws the line at losing commutativity. But I don't know. Like, what about the integer quaternions? I don't know. Those are pretty number-esque, or like Z mod 6. Yeah, Z mod 12 is clock math. That's pretty numerical. Broke numbers on a clock are numbers. Woke holomorphic function is a number. Okay. Should I do some math soon? Should I do some actual math soon? Just waiting for math questions to roll in chat. This is what happens when I stream this early. This is what happens when I wake up early and I stream early and everyone's in bed. Maybe on the weekend I should do an afternoon stream or something. Switch it up to the afternoon. Been reading a lot about rigid geometry recently. These notes of Kedlaya. I don't know how you say his name. Is that how you say his name? He mentions in the historical notes section that Tate has been lecturing on the topic. Had been lecturing on the topic early in the early 60s. You have many math questions. Well, you better ask him. That's what I'm here for. This is office hours. He steadfastly refused to publish them until they eventually ended up in the hands of the editors and got published in 1971. Oh, Growth and Deke was cast in shade. Hello, Noel. Good morning. Tate didn't publish much. Vaguely recall a story of someone submitting something in his name because he didn't want to write it up. Yeah. His thesis was published at the end of the notes from an unrelated conference 17 years later. Wow, really? Yeah, I don't know. I wonder if he has some sort of like inferiority complex or something. It was asked to you in an oral exam yesterday and couldn't answer it. Okay, well, interesting. I mean, I don't know if I'll be able to answer a random oral exam on the spot, but please, yeah, put it in chat, and we can talk about it. Cola. What's that? What's that from? What's that term from? Like, what language is that term from? It's afternoon in Europe. Oh, okay. Well then, mission accomplished. I'm already streaming for my afternoon followers. Although, I guess I should specify. I should maybe do some streams for my afternoon. Um, yeah. Yeah, but I do remember. I do remember. What was he saying? I got very annoyed. I got very annoyed at. I think it was Tate's Obel lecture interview, which is on YouTube. Um, and he. Yeah, what was he saying? He was like, "Oh yeah, he's really downplaying his thesis," and I just thought that was so annoying. Because it's like, okay, dude, even if you personally didn't think it was that great in the face of all the research contributions you made, it's like the most famous PhD thesis in the world. Like, probably one of the most cited. Well, okay, I don't know. There's the citations are way higher in other fields, but adjusting for that variable, I'm like, come on, like who else in the world did you just say their last name? Oh, this person's thesis, and you know who they're talking about, and you know the paper, and you know what's in it. Like, uh, I don't know. So maybe he just had really serious self doubt issues. I don't know. Okay, so what was this question? So show that for all x in here, cos of sine. Oh, this is a cool problem. Cos of sine is strictly greater than sine of cos. Interesting. I wonder, yeah. I definitely don't remember any of my trig laws, if that's going to be helpful here. Do I like Keith Conrad's Expo papers? Yes. In fact, just the other day, I was ranting on stream about how you need to know. Everyone should know Keith Conrad, and he's the goat of exposition, and highly recommend him. But you just didn't like it. I feel like everyone's always glazing his papers, so maybe it's just me. I mean, they really helped me get through my first algebraic number theory course. There was just certain computations in there and stuff that was, yeah, I found really helpful that he went through those and say, like, those same detailed computations. For example, I don't think Marcus went over them. So in France, colle. Well, I don't know the right French way to say it. I've started trying to learn a little bit of French because I'm going to Quebec City this summer. And yeah, it's very French, so probably brushing up on my French. In France, it means an oral exam at undergrad competitive level. Okay. Yeah. Is f of x equal to x squared a flat morphism? Well, we can talk about that in a second, but I mean, you mean in like from any ring to itself? Or like what's the domain and range? Okay. Show that for all x in R that this is true. Well, I have no idea. I mean, I'm tempted to say, so if we can prove I mean, immediately I had the thought of taking a derivative. I don't know if that's helpful, But I was gonna say, oh, if we can show, if we can show it's like increasing, if we can find somewhere that it's non-zero and then prove it's increasing, but that only works from the point that we start off beyond. Um, well, yeah, let's just guarantee that it works at a point. So if we plug in 0, this is cos of 1. I also wonder, like, is it helpful to use the complex formulas, like the I mean, sorry, like a bunch of trig identities are probably going to be useful here. But I mean, like, if we took sine x and what is it? I see. I don't even remember the formulas anymore. Something like this. I wonder if that could be helpful. Yeah. You ask Google cosine x minus sine cos x graph. Yeah, that's a good idea. But I mean, let's imagine we're on an oral exam. Well, then, should I even look up? Should I even look up the equations if I'm not on an oral exam? I don't know. Let me just take a derivative. I just want to take a derivative, anyways. I have no idea if this will be helpful. So, well, this would be minus sine of sine x times cos x. And I guess I'll put this, I'll move it over and I'll take like the derivative of the whole thing. And then this will be cos of cos x times minus sine x. So minus sine squared x cos x. Or no, not squared. Ugh, gross. That's sine of sine, right? Yeah, okay, no. This isn't helpful at all. Yeah, what are the algebraic okay, this is my mock oral exam, so I have to not look up the equations. But then again, I didn't know I would be doing an exam on cos, so I'm gonna cheat anyways. Ha 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 ha. Let's see. I'm not going to read these notes. I should, but I'm not going to. Cos exponential form. Cos is the plus. Cos is the plus, and sine is the minus with the 2i in the basement. Okay. So cos. So this becomes, right, cos is this. Sine is this. So we get what? I sine x plus e minus I sine x. I'm gonna work backwards from the identity. I'm gonna also immediately clear the 2's in the denominators. Now, yeah, right as Christian said their message, doubt this is fruitful, yeah, because the problem is these are both real numbers, and then as soon as if I tried to multiply the I, this becomes meaningless. It's complex, so I don't have this equality anymore. You're allowed. You got a 6 out of 20 out of pity because you only did one exercise. Oh, well. It happens. It happens. Hmm. I'm sure there's some easy trick to this one. Show that cos of sine. Yeah, I have no idea. I kind of want to be a physicist about it, and I don't know, do a, plug in some series and say, well, I don't know. I mean, okay, this is probably not a worthwhile approach, but I'm imagining, you write these out as series, plug one into the other, right? You get these series expansions on both sides, and then maybe you prove, like, maybe, you can work out like the second order and third order terms or something, and then you can prove that, like, well, if you take the cutoff to the third order terms, that it holds, and then prove, I don't know, by induction or something, that it holds for the higher order curves. So could be. Um, yeah. Okay, so I don't know. Am I gonna give up here? I might give up here. I might give up here to do the algebraic geometry question in the chat. Uh, Even though this question is probably easier in some sense. Well, easier in terms of conceptual overhead, but obviously there's some trick. I mean, I wonder, like, could you take like a cos inverse or something? An inverse cos, because like an inverse sine will be something like an inverse sine will be something like this. That'll be like increasing or something, right? So if you took like if you took like an inverse sine here, and you got cos x. Oh yeah, yeah. Christian just mentioned. I think you need to consider the images of cos and sine on -1, 1. Ah, yeah, that's true. Right, that's true. Ah, okay. So maybe you could get away with a derivative trick, right? Because the range the range of sine here is -1, 1, and same with cos here. So like if you could prove, I guess, yeah, you could definitely there's something going on here, and I wonder, like, mind you, the derivative's kind of gross, so I don't know if that actually is helpful, but yeah, we can just restrict it to there. You tried DL series expansion and defining for all x that to prove it is positive, but could not figure it out. Hmm. Can't you just use the fact that sine in absolute value is less than 1, less or equal to 1, less than pi over 2? Probably you could. Well, let me rewrite it down here. So we have what? Cos of sine greater than sine of cos. And yeah, so sine definitely, yeah, absolute value sine x is bounded by 1. And that'll be less than pi over 2, but I don't, but where we go after that? Where do we go after that? Oh, I see what you're saying, because then, right, so that means, right, over here, so then that means that in particular cos of sine of x, this will be greater than or equal to Um, Let me think. gotta draw my circle. So, well, wait a second. Pi over 2? Um, um, or do I wanna take I wanna take an even better bound. I wanna take even like pi over 4 or something. Or is that too small? I have like no idea numerically. No, because pi is about 3, so that's too small. That'd be less than 1. Um, right, so that is pi over 2. Uh, that's Richard. I think you're on the right track here, but somehow that bound isn't good enough, right? Um, yeah, yeah, you're right. This will be bigger than cos 1, but I mean, uh, well, mind you, I guess cos 1's pretty small, right? Cos is down here. Aha, so cos 1, I suppose. Um, I suppose pi. As a physicist, you can tell me that pi is exactly 3. Thank you. I'm glad we had someone. Yeah, as a mathematician, I can't tell you what any of the digits of pi are. I can just tell you it's a transcendental number. Right, I don't remember any of my rules. Was I? We could say it's at least this, right? We could say it's at least this, because this is like at pi over 6. At pi over 6, it's root 3 over 2. Um, yeah, and then yeah, exactly. So then sine of cos is going to be less than or equal to sine 1. Yeah. Wow, it's not even me who helped you. It's chat, really. But you guys all know about this mind-blowing trick. Actually, let me see. Yeah, probably you can see my hand. I don't know. I don't know. Maybe it's backwards. Maybe it's backwards for you. But so was it cos? So cos at 0 is root 4 over 2. Cos at pi over 6 is root 3 over 2. Cos at pi over 4 is root 2 over 2. Cos at pi over 3 is root 1 over 2. And cos at pi over 2 is root 0 over 2. Isn't that the greatest thing you've ever seen? I think it's the greatest thing I've ever seen. Like, oh yeah, I do all perversies, all Langland's infinity category, oh, so fancy, blah, 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 blah. But at the end of the day, I mean, that's like my favorite thing. You think you only need to prove this inequality for x less than pi? Yeah. I think we can consider this one done. We can consider this one solved. So now we can jump over to we'll do don't get whiplash. Don't get whiplash. Man, I gotta remember to turn off my group chats before I stream always. Who knows what things will pop up in group chat on stream. That wasn't so bad, but you know. Okay. What was I doing? Oh yeah, algebraic geometry. We're making a crazy transition from trigonometry to algebraic geometry. Okay, so what was the question? We want to look at the map of, well, what am I doing? I mean, it should be the map from A1 to A1. Well, actually, um, I guess I should clarify. I think originally it was asked to look at the map given by squaring, but now I'm unsure. Did they mean to take like A1 to A1 and square the points, or did they mean that the map going in the that it should be the map that corresponds to going in the other direction, um, given by squaring the polynomial? So no, who asked that? Let me check. Paul Maurice. Yeah, I don't know if you're still here. If you're still here, maybe let me know which version of this you were trying to do. And what actually is the? I mean, I'm trying to think. What's the even? I gotta remind myself. Well, okay. What I mean, I guess we need to. Maybe I should write this as like goes to a squared, and so actually, if we took the I don't know what do we call it, F sharp, the map going between the coordinate rings on the other end. Well, I guess I need to write this. I guess I need to write this in terms of ideals. So this would really be the map that takes the prime ideal x minus a and sends it to the ideal x minus a squared. Right, that's what it'd be in a ideal theoretic language. And so then, so viewing this, so I'm viewing this now as a map from here to here. And, right, so that sends x minus a to x minus a squared. And now what is the induced map on the rings? What's the corresponding map on the rings? I don't remember. It's been that long since I've written down like an affine scheme and the correspondence map. Actually, I have to look it up. I have to look it up. You know, I do want to make a series on it sometime soon on basic affine scheme computations. Bum bum bum. Maybe NLab. No, NLab's going to be way too abstract. That's not going to tell me what the inverse map is. I mean, it should just be... It's like... This, like, induces a map on the structure sheaf or something? Yeah, what is it? I mean, technically it should be what? It's like you push forward the you get like you pull back one of the structure sheafs and then you get a natural map from the structure sheaf of one to the other. God, I should really know this. Is there no one in chat who who can help me? Who can remind me the formula? should probably just look up Hartshorne. Yeah, but what's the correspondence between the functions and the ideals? Blah, blah, blah. F from X to Y gives you a map there. Okay, thank you. Thank you, Noel. I knew it was something like that. I thought it was a push forward, but it makes more sense as a pullback because this is the contravariant functor. You don't understand what I'm asking? Maybe I don't either. But I think this is what I wanted. This is what I wanted, right? This is the map. So this should be, yeah, from OY into the push forward OX. And how is that map given? I can't remember. So is the office hours from what, 7 most days? I don't know. I have no regular schedule. Probably my office hours would be more popular and my channel would be more successful if I kept to a regular schedule. But the truth is, it's all over the place. It'd be interesting to look at the statistics and see. Probably you're right. I spilled some of my precious coffee. Probably you're right. Close to 7 most days. But it just kind of depends on when I wake up and what else I have going on during the day. Right. And that map, how's that map given? Let's think, because this would be right. This will be like okay, if I had some open set of Y, I gotta remember. Here I am making sheaf theory videos, and I don't even remember my basic sheaf theory. Gotta figure out what the map is here. And what's that? That's just the pullback map here. Right. And so how should F sharp map OY into OX F inverse U? I gotta look that up too. God, what do I even look up? Map from OY to F ast OX? Yeah, but he's asking a question about it. Just open Hartshorne at this point. Yeah, I should. You're right. So you guys really find out how little I truly know. At least off the top of my head. Well, this will be in like 2.1 or something. Hey, this PDF ain't behaving. Schemes. A little too far. Still a little too far. Isn't this exciting? Hello, do I have plans on becoming Pope in the future? Well, we were actually chatting about this very real possibility earlier. Yes. Yeah, the new Pope, whatever his name is, has paved the way for me. So I think it's probably the most viable option. I bet you it's here in the exercises, isn't it? I mean, it should be. This is a general sheaf statement, so it should be in the chapter on sheaves, right? Maybe not, because I guess it's technically. Well, because I guess it's the structure sheaves, right? I mean, I think chapter 2 he talks about the explicit maps for the affine scheme, so maybe it is in 2.2. Maybe it is here. Let's see. Are you guys entertained right now or what? It's in the text on the affine scheme. Yeah. Okay. Well, here we go. A morphism. Oh, wait a second. He defines a morphism of ringed spaces to come equipped with a map like that. How long do you think a person can take to learn the definition of a sheaf without knowing basic category theory or topological spaces? Without knowing topological spaces, it is going to be a little difficult. You could go start watching my sheaf series now, though. But probably in order to get it, you should know a little bit about topological spaces. Like, at least, I mean, have you seen metric spaces before? Have you at least done, like, do you know what, like, how to, like, rigorously prove something is a continuous function from R to R, for example? You mean it's not too hard, it's just the obvious map. If you look at the definition of the structure sheaf, then it should be clear what the map is. You're probably right, but yeah. Because that was you 2 years ago when you saw the definition of a sheaf. Right. I mean, okay. I guess, I guess I just need to. But I mean, yeah, here, I mean, let me rely on Hartshorne again because, he does prove that it should be entirely determined by a homomorphism of rings, right? Phi. Well, I guess phi uniquely determines the pair. This should not have taken as long. This should not have taken as longer than the question about. Whatever. The question about cosines and stuff. I don't want to leave before doing this, but the coffee is getting low. Okay, so what is the ring map? We need a homomorphism of rings where if I took the inverse image of the ideal of this ideal, I would get this ideal. And the brain is not braining today. I'm really smooth braining it today. I mean, if phi was what? I mean, I feel like somehow it should be if it was a squaring map of sorts. Oh, time to wake up. That was my alarm. Yeah, I've got no idea. I mean, what are our ring morphisms? What are our ring morphisms here, anyways? I don't think we have a lot. For some reason, this ring space kind of loosely got you thinking about Banach algebras. Is there a connection? No idea. I mean, well, the whole enterprise of associating maximal ideals to points uh, comes out of like functional analysis. I don't know specifically Banach algebras, but so I mean, there's that. There's that, but beyond that, I'm not sure there's anything special about this question and its relation to Banach algebras. Um, I mean, what the hell morphisms do we have between polynomial rings, anyways? We should certainly have all the, well, can we even square things? I mean, that's actually a good question. What are even the ring homomorphisms? No such map exists. Okay. Yeah, I can believe it. So then maybe I was wrong. I mean, the person who originally the person well, the person who originally asked the question didn't really specify, but maybe it was on me. I should have picked up what they meant. So they said for an algebraically closed field, yeah, they wanted to show that this map where we square from A1 to A1, where we square points, um, is what did they want? I guess they wanted to see if it was a flat morphism. Um, you prefer the stack notes over Hartshorne? Like you mean Stack Overflow? Or not Overflow, I mean the Stacks project? That's probably a better place to go. Yeah. Um, but Hartshorne's it's called culture, sweaty. Algebraic geometry culture. So probably what they meant is this. Probably what they meant is probably what we could compute instead is this ring homomorphism. Wait, is this even no, wait a second. That's not even a ring homomorphism. I was about to write down something unless we're in characteristic 2. I was about to write the squaring map. Uh, um, yeah, so okay, I guess we just spent like half an hour on a question that doesn't even really make sense. Uh, welcome to mathematics. That's how we do it. Well, I feel like that's the perfect anticlimactic note to end on. Hi, Arcturus. Well, you came at the worst time. I was just about to leave. So, yeah. Sometimes math do be like that. You just run in a circle and end up nowhere. What would it be the intuition for this map of sheaves? Wait, which map of sheaves? I will correct all of these errors. That's not true. I'll correct some of these errors in the near-ish future. Uh, uh, I'll correct some of these errors in the nearest future. I do plan to put up some basic videos about affine schemes and eventually get back to sheaves soon. Priority 1, I really want to finish the script for the next categories of modules video because I sunk way too much time into it already because I went down a rabbit hole of trying to prove a whole bunch of things really rigorously with diagram chases. And I have no idea who wants to watch me do some tedious diagram chases that they could easily do themselves for like an hour. But someone is. Someone will watch that. A very small portion of my viewers. So keep your eyes open because that's coming. Definitely by next week. Okay. Well, now that I've wasted a bunch of your time, time to go prove some actual theorems. Hey, no one last time, no one told me where I assumed algebraic closedness in yesterday's stream. So shame on all of you for not doing your homework. Sorry, something else popped up in chat. Would love to watch you do diagram chasing. The bigger the graph, the better. Okay, well, stay tuned then. You're gonna be in luck. Okay, but till then, go prove some things.